Hey everyone! In this video, we're going to be taking a look at implicit differentiation. So what this is it's a method that allows us to find the derivative of functions or equations that are defined implicitly. What that means is the equation is defined in terms of x and y instead of just x. So the process for implicit differentiation, what we're going to do is we're going to take the derivative of both sides of our equation with respect to x, and then we're going to solve that equation for dy over dx. Now remember that notation, dy over dx, that's our notation that represents the derivative of the equation y with respect to x. So if we're able to solve for that, that's going to be our derivative. So let's just go through that process by taking a look at an example. Now, while we go through this, we are going to need to use some of our other methods as well. We may need to use the product rule or the quotient rule, or we may need to use the power rule as well. So here's my equation. X squared minus x times y squared is equal to 4y. So again, this is an equation that is defined implicitly. It's an equation that's defined in terms of x and y. Right? The y is not all by itself, where everything else is in terms of x. So the first thing is we're going to take the derivative of both sides with respect to x. So I'm going to take the derivative with respect to x, d over dx, of both sides of this equation. All right, so now we need to go through and we're going to find the derivative with respect to x for each of these parts. So on the left-hand side here, I can use my difference rule for derivatives, and I end up with the derivative of x squared minus the derivative of my second term, xy squared. And I still have the derivative with respect to x of 4y on the other side of the equation. Okay, when I take the derivative with respect to x of my variable x, this is what we've been doing. So the derivative with respect to x of x squared using the power rule, this is just equal to 2x. Now when I move on to my second term here, I actually have two pieces that are being multiplied together. So I actually have to use the product rule to find the derivative of this. So I'm going to put this in parentheses. So the product rule, we're going to do the first times the derivative of the second. So we have x times the derivative of our second piece, which is y squared. And then plus, we're going to do the derivative of the first, so d over dx of x, and we'll multiply that by the second piece, which is y squared. And on the other side, we still have d over dx of 4y. So now as we keep going, now I can talk about what we do when we take the derivative of the variable y. So inside the parentheses here, I have x, and then I'm taking the derivative with respect to x of y squared. So we can still do this, and we can still use all of our normal derivative rules. However, I need to include one extra thing. So y squared, the derivative of this, using the power rule, this is equal to 2y. But now since I'm taking the derivative with respect to x, I'm actually going to include dy over dx to indicate that we took the derivative with respect to x. In my second part here, the derivative of x, this is just equal to 1. And since it's the variable x, we don't need to include dy over dx. So we just end up with 1 times y squared. Okay, on the other side of the equal sign, this is the same idea. So I'm taking the derivative with respect to x of 4y. Using our normal derivative rules, the derivative of 4y is just 4, but I also need to include dy over dx. So there we go. Took the derivative of everything, and as you can see, I am left with dy over dx in a couple spots in this equation. So then the next step, what we're going to do is we're going to solve for dy over dx. So the first thing, I'm going to distribute this negative sign. So we get 2x, and this is going to be minus 2xy times dy over dx, and then minus a y squared. So I'm going to solve for dy over dx, and basically I'm treating that as a variable. So I just want to rearrange this equation so that I can isolate dy over dx. So to do that, let's get both terms that have dy over dx on the same side of the equation. So I'm going to add this 2xy times dy over dx to both sides. And that leaves me with 2x minus y squared. That's equal to 4 dy over dx plus 2xy dy over dx. Now the next thing I can do, on the right-hand side of this equation, both of these terms have a dy over dx. So why don't we factor that out? So if we factor it out, we have dy over dx times, and what we're left with, we have 4 plus 2xy. And here we have some multiplication. So then the last step, to get dy over dx all by itself, we'll divide both sides by 4 plus 2xy. So the derivative, using implicit differentiation, we end up with 2x minus y squared all over 2xy plus 4. And because dy over dx, that's our notation that represents the derivative with respect to x, here's our derivative of our equation.